4.14 Data Backup, Storage and Restoration. Hello everyone, I'm Yazan Ibrahim, or as some of you might know me, Yazan Abu Ghosh. Today we're going to dive into a fascinating and essential topic from Chapter 4, Part B, Business Resilience, 4.14 Data Backup, Storage and Restoration. If you're a seasoned auditor or just curious to understand how information systems into business environments, you've come to the right place. Let's begin. Data is the lifeblood of any modern organization. Imagine for just a moment a day where all your business-critical data vanishes. Transaction logs gone, customer histories erased, operational systems crippled. This dramatic thought underscores an essential business truth. Safeguarding data isn't just a technical task, it's a strategic priority. Let's delve into the fascinating world of data backup, storage, and restoration, not just concepts, but the very foundation of business continuity and resilience. The core premise: why data backup matters. In today's fast-paced digital world, data is a key asset to nearly every enterprise. Organizations rely on robust data structures for operations, decision-making, customer service, and profit generation. That's why keeping data safe is critical, not only for operational continuity, but also for industry compliance, particularly when laws and regulations dictate how sensitive data should be stored and handled. Our journey into this subject begins with resilience, how businesses prepare for the unexpected. Let's dive into data storage resiliency and disaster recovery methods, a fascinating aspect of system architecture that sets the backbone for successful data protection. Data storage resiliency, protecting against the unforeseen. One of the most common and fundamental strategies used to ensure data resiliency is something called RAID, or redundant array of independent or inexpensive disks. Imagine splitting up your data into fragments and seamlessly distributing it across multiple disks. That's what RAID does. By doing so, it not only improves system performance, but also creates fault-tolerant configurations, meaning if one disk fails, your data remains intact. There are multiple RAID configurations: RAID 0, RAID 1, RAID 5, or more complex combinations like RAID 0 plus 1 or RAID 10, all designed to meet different needs for performance or redundancy. For example, RAID 0 is all about speed, while RAID 1 focuses on mirroring data for safety. Higher levels like RAID 5 balance performance and fault tolerance. While understanding RAID in exhaustive detail isn't required here, it's necessary to grasp its core purpose: minimizing single points of failure. These strategies are often implemented through hardware-based storage arrays. These come with sophisticated technologies that abstract away the complexities of RAID, offering IT teams easy-to-use interfaces while also enabling advanced capabilities like data replication. Replication, data clones across sites. Here's where things get really interesting. To protect against physical disasters, replication technologies ensure that data exists in not just one, but two or more locations. Picture this. As data is written at one site, it's immediately or periodically duplicated at another site, often located miles or even continents away. This replication can happen in different flavors. Synchronous replication ensures that data writes are confirmed only once they're saved at both the primary and secondary locations, guaranteeing absolute accuracy. Asynchronous replication, on the other hand, allows for some delay, trading off real-time duplication for efficiency when bandwidth or latency could be a bottleneck. Adaptive replication is a hybrid, dynamically switching between modes based on real-time conditions. These techniques might sound esoteric, but they're critical for large-scale infrastructures. They ensure that even if disaster strikes one location, operations can quickly recover at the backup site without skipping a beat. Backup and restoration, safety nets in a digital world. Replication is impressive, but backups are non-negotiable. Backups form the bedrock of any business continuity plan. These snapshots of data provide the ultimate safety net, ensuring that systems, no matter the scenario, can always be restored to operational status. Organizations use various media to store backed up data. These include removable media, things like tape cartridges, CDs, DVDs, or portable drives; mirrored disks, high-speed local or remote storage solutions; network storage solutions, centralized repositories accessible via network connections. The strategy here is clear. Off-site backup libraries ensure that even if a catastrophic on-site event occurs, such as a fire at the data center, your business has a remote lifeline of untouched information ready to restore operations. Safeguarding the off-site library. But what if disaster doesn't just destroy your primary systems, but also jeopardizes this off-site archive? This is where stringent controls come into play. From physical security to encrypted backups in transit, Every aspect of handling offsite media must be tightly regulated. For example, backup libraries are placed in secured facilities far enough from the data center to avoid being affected by the same natural or malicious disasters. These facilities are specially constructed to withstand fire, water damage, and other environmental risks. A complete inventory of every backup medium and its contents is maintained and secured for legal and operational use. Beyond the physical, logical security is paramount. Encryption ensures that sensitive data remains protected even if backup drives are intercepted during transportation. And regular audits of these systems keep every piece of the backup infrastructure functioning as it should. Choosing the right backup media, balancing capacity, speed, and cost. Modern organizations have many choices when it comes to backup devices and media. The decision hinges on striking a balance between standardization, capacity, speed, and cost. Some of the most common approaches include tape-based systems. These are great for large volumes and long-term storage. Modern systems even feature robotic arms and barcode scanners for efficient management. Disk-based backups. Faster and more flexible, these include technologies like virtual tape libraries, VTLs, disk snapshots, and replication. Cloud-based backups. Beyond physical solutions, organizations now leverage cloud services that combine scalability and redundancy across distributed servers worldwide, but it doesn't end here. The backup scheme and its scheduling frequency define how effective an organization's recovery plan will be. Backup schemes, full, incremental, and differential. The backup scheme defines the approach to creating backup copies. 1. Full backups. Every single file and folder are copied, which is resource intensive but ensures simplicity during restoration. 2. Incremental backups. Only data that changed since the last full or incremental backup is copied. It's fast, but can complicate restoration since multiple segments must be pieced together. 3. Differential backups. This method covers all changes since the last full backup, balancing speed and ease of restoration by requiring only the full backup and the most recent differential copy. Organizations often use combinations of these schemes to optimize time and storage space while ensuring recovery objectives are met. The grandfather-father-son rotation method. Finally, let's talk about rotation, the process of cycling through backup copies. A widely used approach is the grandfather-father-son method. Daily backups, son, occur each day and cycle weekly. The final weekly backup, father, is retained and cycled monthly. Monthly backups, grandfather, are stored for long-term retention, often indefinitely. This tiered structure ensures redundancy, providing multiple layers of recovery even if one copy is compromised. Restoration, the real test of preparedness. All these best practices lead to one critical question. Can you restore data when it's needed? Testing backup and disaster recovery plans is the true measure of a strategy's effectiveness. Regularly scheduled tests help uncover gaps, verify assumptions, and ensure personnel are prepared to execute plans under high-pressure situations. Every recovery process must be documented with key reports on testing timelines, performance outcomes, and the resolution of potential issues. Without testing, a disaster recovery strategy is little more than an unproven theory. A final word, securing the future. With the digital revolution comes the undeniable responsibility of protecting an organization's critical data. From RAID configurations to disk-based backups, from rotational schemes to rigorous offsite controls, a solid backup strategy is not only about recovery, it's about resilience and continuity. As we've explored today, these are the keystones of a modern enterprise, ensuring that no matter the storm, the ship continues to sail. The question isn't if disruptions will happen, but rather, when. Preparedness is key, and your organization's ability to bounce back from disaster lies in the strength of these foundations. This concludes an overview of data backup, storage, and restoration. Together, these efforts form the invisible framework keeping the digital world and businesses running smoothly every day. Thank you for watching, and as always, continue learning. Stay curious, and we'll see you next video.